All right, this is day 2 of simplifying expressions using the exponent rules. And so quick review of what we talked about last time is that a 0 exponent, anytime you raise something to the 0 power, it's 1, no matter how ugly it is. If you see a negative exponent, that means it's on the wrong side of the fraction bar. And so you move it to the other side of the fraction bar and you make it positive. Product of powers means you're multiplying 2 powers with the same base, and then you would add the exponents. A quotient means you are dividing 2 powers with the same base, and here you would be subtracting the bottom from the top. Okay, and so let's do some examples. Here, everything's being multiplied by everything, and so the parentheses aren't necessary. There's nothing to distribute. You can separate each one with a multiplication dot if you want to. And so I like to put the coefficients out front. So coefficients are these big numbers without an exponent. They're not a base. That's important. And so those coefficients are going to come out front and they're being multiplied. Okay. And then next I focus on the a's. I have a to the negative 6. And then I have a to the 12th. And so when I write the a, I'm going to add those exponents. I'll worry about the negative later. Usually they get resolved along the way. Next, I have b to the negative 5th and b to the 1/2. And so I'm going to add negative 5 and 1/2. And then lastly, we just have a c with no other c's. And so we're just going to have a c to the 3rd power at the end. Okay, and so simplifying this, 2 times 3 is 6. Negative 6 plus 12 is going to give me a to the 6. To do negative 5 plus 1/2, we need a common denominator. And so I would multiply top and bottom by 2 to get negative 10 over 2 plus 1/2. Negative 10 halves plus 1/2 is negative 9 halves. So b to the negative 9 halves, and then the c to the 3rd power. Now before we commit to our final answer, we have a negative exponent, so only that term is going to move. And so everything else except the b term is going to remain on top. I'm going to add a fraction bar and put b to the positive 9 halves on bottom. Okay, and so you can apply the exponent rules really in any order. For me, it's easiest to take care of negatives in the very last step. Sometimes like this, it got resolved along the way. And so go ahead and do the rule of addition. And then if you're left with a negative, that's when you can move it to the correct side. Otherwise, you're just going to be moving it back. And so wait till the end to take care of negatives. Okay, here I have a fraction bar, and so your answer only gets one fraction bar. We're not going to have fractions within fractions unless it's an exponent. Okay, and so focusing on our coefficients first, those don't have exponents, and so we simplify that as we usually do, negative 32 over 10. And so both of those can be divided by 2, and so negative 16 over 5 would be our simplified fraction. Next, we're looking at the m's. And so m to the 8th over m to the 4th. This is where we use the rule of subtraction. So 8 minus the 4 top minus the bottom. And that gives me m to the 4th. That is a positive exponent. So m to the 4th would be written on top. And then lastly, we have n to the 3rd and n to the 6th. N to the 3rd over n to the 6th. That would be 3 minus the 6, which would give me n to the negative 3, which means n to the positive 3 really should have been on bottom. And we can see that. We have more copies of n being multiplied on bottom, and so as they cancel, we would be left with more copies on bottom. So I'm going to write n to the 3rd power below the fraction. So my final answer, 1 fraction, negative 16m to the 4th, over 5n to the 3rd. All right, this next one, we haven't talked about a 1/3 power. We talked about how anything to the 1/2 power is the same thing as a square root. And so, for example, if I took a perfect square like 16 to the 1/2 power, that would be the square root of 16, which we know is 4. And so likewise, a 1/3 power is what we call a cube root, okay? And so a square root unsquares things, a cube root uncubes things. So we're trying to figure out what cubed would have given me 125, okay? And so that answer is 5. And so that means the cube root of 125 is equal to 5. And so if you don't have a calculator, you're basically just asking yourself, what cubed would have given you this 125? Of course, if you do have the calculator, you can just raise it to the 1/3 power and see that it's 5. Okay. And so now we're going to discover some new rules. One is when you have 2 exponents on one base. Okay, 2 exponents on one base gets multiplied. And so to show you an example, if I had a squared cubed, that means I have 3 copies of a squared being multiplied. And then if I were to expand that even further, I would have 2 copies times 2 copies times 2 copies. That's a total of 6 copies of a. And so when you see 2 exponents on one base, you multiply them. If you have the base written twice, like we do here, that's when you add them, okay? And so the base written twice, that's when you add. If you don't have the base written twice, that's when you multiply. So some way to visualize this is M and N are right next to each other like that, you're going to multiply. Okay, and then the other rule is if you have a product inside your parentheses, you can distribute that exponent to each term in the product. Okay, this only works for products, not plus signs, and so just be careful when you start distributing exponents. We'll talk about that in a later lesson. Okay, here, you could go ahead and do 2 squared and get 4. 4 cubed is 64. Or using our rules of exponents, we would multiply 2 times 3 and get 2 to the 6, which would also give us 64. Okay, here 6 and 7 are on the same base, and so we multiply to get 42. Okay, thinking about what would happen if I were to expand all these x's out, I'd have 42 of them on the board. Okay, next up, if you have a coefficient and he's inside the parentheses with the exponent, he also gets the exponent. So just be very careful when you write that. When he gets the exponent, that -7 is the base, 4 is the exponent. Never, ever, ever multiply a base by the exponent. Something I say often is never multiply a big number by a little number. You will never do that, okay? The base does not get multiplied. So a lot of people will say this is -28. It is not -28. -7. Make sure you use your parentheses because that negative needs to be raised to the 4th power as well. Gives us positive 2401. If you don't use those parentheses, they're going to keep the negative. And anything raised to an even power becomes positive. Okay, and then this x already had an exponent, so those exponents get multiplied. So you can multiply little number by little number, never multiply a big number by a little number. Okay, and so that would be x to the 28. Okay, little numbers can be multiplied. Big numbers do not get multiplied by those exponents. Okay, next, every term gets the square. So -3 is our coefficient. He's going to get squared. X to the 4th already had an exponent, so those get multiplied. Y already had an exponent, so those get multiplied. z already had an exponent, so those get multiplied. Okay, so just to reiterate, little numbers can be multiplied, big numbers cannot, okay? And so negative 3 squared is actually positive 9. And then we would get x to the 8th, y to the 16th, and then z to the 18th for our final answer. Okay, next step, every term gets the 1/2 as an exponent. So 16 gets 1/2 as the exponent. X already had an exponent, so his exponents get multiplied. Y already had an exponent, so those exponents get multiplied. 16 to the 1/2 power we talked about is the same thing as a square root. A lot of people say that's 8. It is not 8, it is 4. We're taking the square root. We are not multiplying a big number by a little number. Okay, can't stress that enough. I see that mistake all the time. This is your base, this is your exponent. Okay, both of these are exponents. Both of these are exponents, so that's why they can be multiplied. So 4 times 1/2 is 2. 8 times 1/2 is 4, just dividing by 2 when you multiply by 1/2. So our final answer is x squared, y 4th with the 4 out front. Okay, last one, most challenging one. Every term inside these parentheses are going to get a 1/3 power. 8 is the coefficient, he gets the 1/3 power. A is the base, he already had an exponent, so those exponents get multiplied. B is the base, 15 is the exponent, and now we're giving him another exponent, so they get multiplied. And then this 2ab to the 7th, there's nothing to distribute, and so we just write it down. And I like to put multiplication dots just to remind myself everything's getting multiplied by everything. We don't have to keep anything as a group after the distribution. Okay, 8 to the 1/3, we're asking ourselves or just told you the answer. What to the 3rd power would have given me 8? And that answer is 2. And so 8 to the 1/3 power is 2. If you have your calculator, you can verify that 8 to the 1/3 power is 2. And then now we're multiplying. So 6 times 1/3 is just 2. Multiplying by 1/3 is the same as dividing by 3. And then 15 times 1/3 is 5. Okay, and so that's a B, not a 6. So just be careful there. Make it more like a B. Okay, and so multiplying by 1/3 is the same as dividing by 3. Raising to the 1/3 power is the same as taking a cube root. Okay, 8 is the base. All right, and then we still have a times 2 times a times b to the 7th. So just remember, everything's getting multiplied here. And so we can bring our coefficients, the ones without exponents, to the front, and we're still multiplying those. And then we have a's. We have a squared and a to the 1, so those exponents get added. And then we have b to the 5th and b to the 7th being multiplied, so 5 plus 7 in the exponent. All right, so finally, our final answer is 4a to the 3rd, b to the 12th. That's as challenging as it can get. We went through a lot of different steps there. Right, and so some application problems is finding the area of a circle. And so here they are telling me that the radius of a circle is represented by 4a to the 4th b squared. Find the area of the circle if the formula is a equals pi r squared. So for more complicated formulas that aren't just area of a rectangle, they will give you the formulas. Okay, and so the first thing I do is I rewrite the formula. We have an r squared here. We're dealing with enough exponents. And so for that formula, I rewrite it as pi r times r. Pi r. It's the same thing as r squared, but now I don't have an extra exponent hanging around, and it just keeps people from making careless mistakes. Okay, and so pi is going to be in our final answer. We're not going to approximate it. We're just going to leave him, and that's how they usually keep the answers. Okay, and so we have the radius written twice. and they told me what the radius was. It's represented by 4a to the 4th b squared. And so I'm going to write that twice. 4a to the 4th b squared. 4a to the 4th b squared. Okay, and so just ignoring pi, he's just along for the ride, I have coefficients. 4 and 4 do not have exponents, so we're going to bring those to the front. I have two a terms, a to the 4th, a to the 4th, so I would add those exponents. Then I have b squared, I would add those exponents. Okay, 4 times 4 is 16, so we're going to put that in front of the pi, 16 pi. And then 4 plus 4 is a to the 8th, and then 2 plus 2 would give me b to the 4th. And so this is how you would leave your final answer, 16 pi, a to the 8th, b to the 4th. Don't approximate the pi. All right, here they're telling me the radius of a cylinder is represented by 2x to the 4th y. The height is represented by 7xy. Find the volume of the cylinder if the formula is pi r squared h. And so once again, I don't want that r squared. And so I am going to rewrite this formula as v equals pi r r h. It's the same thing as r squared. Okay, and so they gave me expressions for r, and they gave me an expression for h. Okay, and so r gets written twice, and then h will be written once. Pi r r h, and pi is just along for the ride. Okay, and so I have 2x to the 4th y, 2x to the 4th y, that's my radius, and then my height is just 7xy. All right, so ignoring the pi for now, we'll just keep him here. I have 1, 2, 3 coefficients to bring out front. Everything's just getting multiplied, so we can multiply in any order. And then I have 1, 2, 3 exponents, or 3 x's, and the exponents are 4, 4, and 1. So we're going to add the 4, add the 4, add the 1. And then I also have 3 y terms, and each of those exponents are the invisible 1. And so I'm going to add 1 plus 1 plus 1. Okay, still leaving pi. 2 times 2 is 4 times 7 is 28. And then that leaves me with x to the 9th, y to the 3rd. And so to write your final answer, put the 28 before the pi, and then x to the 9th, y 3rd. All right, last rule is when you have a quotient, a division bar, you can also distribute the exponent. Okay, and so just to think, if that m was an actual number, if I had a over b cubed, that's a over b times a over b times a over b, times itself 3 times. And so of course you see 3 copies of a being multiplied, 3 copies of b being multiplied, and so you can distribute the cube to the top and the bottom. And so here I would have 4 cubed over 7 cubed, which is 64 over 343. Here I would distribute the 1/2, so this would give me 64 to the 1/2 over 9 to the 1/2, which we know 1/2 power is the same as square root. And so square root of 64 is 8, square root of 9 is 3. And so my final answer is just 8/3. Here we got a lot going on. And so everything's inside this 1/3 power. And so everybody's going to get this 1/3 power, the 27, the x, and the y, and the w, and the z, okay? And so I'm going to go ahead and write my fraction bar. And so 27 to the 1/3 power, 27 is the base, 1/3 is the exponent. Next, x is the base. He already had an exponent, and so now his 2 exponents get multiplied. Y is the base, 2 is the exponent, and now he's getting the 1/3 exponent, so those get multiplied. W didn't have an exponent, so he just gets the 1/3. Z already had an exponent, and so now he's getting 2. They're going to get multiplied. Okay, be careful with this 27 to the 1/3 power. 27 is the base, 1/3 is the exponent. We do not multiply those. A lot of people put 9 there, but 27 to the 1/3 power is actually 3. You're cube rooting it. 3 cubed gives you 27, but if you have your calculator, which you will on the star, you can just raise it to the 1/3 power and just prove to you it is 3. Okay, and then now we're ready to multiply. 3 times 1/3 is just 1. Dividing by 3 is the same as multiplying by 1/3. And then y, when you multiply whole numbers, you only multiply the tops and the bottom. So that's technically 2 over 1, so that would give me 2 over 3 when I multiply it by 1/3. W to the 1/3, and then z to the 4/3. Okay, and so for your final answer, they usually don't write exponents of 1. And so if this were multiple choice, you would see this as an option. Okay, here we have a 4a squared out front. And so because we're multiplying by a fraction, I'm going to go ahead and give him a denominator as well. And then the second fraction, he gets this square. So every term, including that 2 in front, gets the square. So that's going to give me a. He already had an exponent, so those get multiplied. And then on bottom, that 2 gets the square. And then a already had an exponent, so now he's getting the square. Okay, don't square the 4. Those are both exponents. They get multiplied. Okay, and so we can add, when we multiply fractions, we just multiply the tops and multiply the bottom. So we can treat this as one big fraction. Okay, and so simplifying the top first, I would have a 4 out front, and then I have an a squared, and then here I have a 6. So I'm going to have 2 plus 6 on top. I'm actually going to take this in 2 steps for the sake of your notes. And so I'm going to go ahead and just rewrite that second a as a to the 6, multiplying the 3 and 2. Okay, and then on bottom, 1 times anything is just itself, so we don't have to rewrite the 1. 2 squared would give me 4. And then 4 times 2 would give me a to the 8th. All right, now, 4 divided by 4 is just 1, so we don't have to write that. Here I've got a squared and a6, so we're going to add those to get a to the 8th. And then on bottom, we have an a to the 8th. And so you could see that those are going to cancel and turn to 1. Don't write 0, because remember, this is technically... And so that would give us a to the 0, which is 1. Okay, for this next example, we have a to the 6, b to the negative 2 on top. On bottom, every term gets that 3. So a already had an exponent, so now he's getting a second one. They get multiplied. B didn't have one, but now he does. Okay, and so just simplifying, we'll worry about negatives at the end. I get a to the negative 6, b to the 3rd. Now that we have a division bar here, that's where we use the rule of subtraction. So for the a's, we're going to do 6 minus negative 6. Okay, and then for the b's, we're going to do negative 2 minus 3. Okay, 6 minus negative is the same as just 6 plus 6, so that's going to give me a to the 12th. And then for the b term, we get negative 5. And so we're not done, because that means b to the positive 5 should have been written on bottom. Leave the a alone. He has a positive exponent. All right, last one here. For the top, every term gets the exponent of 3, okay? And so the 3 gets the 3. A already had an exponent, now he's got 2, so multiply. B already had an exponent, now he's got 2, so multiply. C gets the exponent. And then on bottom, this whole thing is being raised to a 0 power, which means that whole thing is 1. Okay, and so we won't need to write that 1 in the denominator anymore. 3 cubed, 3 raised to the 3rd power is 27, not 9. 3 is your base. This other 3 is your exponent. Don't multiply. This next one we do multiply. 2 times 3 is 6. Negative 4 times 3 is negative 12. And then we have c to the 3rd. And then lastly, before we commit to our final answer, that b needs to move to the bottom. He's the only term that's not where he should be. So move him to the bottom and change that 12 to a positive. Okay, and so let's just summarize all of our rules before we end. And so here, if you have the base written twice, you add the exponents for multiplication. If you have the base written twice and you're dividing, you subtract. If you see a negative exponent, move it to the bottom and make it positive. If you see a 0 exponent, the whole thing turns to a 1. If you have 2 exponents on one base, that's when you multiply them. If you have a product inside the exponent, they all get the exponent. If you have a quotient, division, they also get the exponent. And then if you see a fraction exponent, that's really the nth root of whatever you are taking the exponent of. And so, for example, a 1/2 power was a square root. A 1/3 power was a cube root. And so if you had like a to the 3/2 power, that 3 on top is still your exponent, but that 2 on bottom is your square root. That's something we explore more in Algebra 2.